Yes, am I
Hello,
audible?
everyone. Yeah.
Hello, sir. Good morning, sir. How are you?
Good. How are you? Is my voice
Okay,
clear
okay.
enough?
So, yes, sir. Yes, sir.
Okay,
Yes,
awesome.
students, am I audible? All of you can hear me?
Yes,
Okay.
sir.
Yes, sir.
So good morning. I welcome you all to the guest lecture organized by School of Architecture and Design on Technology and Architecture, Understanding the Relationship through BIM. And the guest speaker, architect Amit Sharma, is here with us. And he is a renowned professional who has worked immensely and handled projects in building information modeling. Architect Sharma did his graduation from Department of Architecture, Guru Nanak Dev University, Amritsar, and in continuation, he received his post-graduation degree in Green Architecture and Building Information Modeling Life Cycle Management from Algonquin College, Ottawa, Canada. And presently, he is working as VDC coordinator in Ellisden, which is one of the leading and renowned construction company worldwide. And now, without taking much time, on behalf of School of Architecture and Design, I would like to call architect Ami Sharma to take charge of this session. And I request students to please maintain the decorum of the meeting and please be attentive. And you can ask the questions in between or after the lecture. And you can also drop message to me or in the chat box or to Ankita ma'am. Okay. So, Architect Amish Sharma, over to you, sir. Welcome
Uh,
to
thank,
the guest lecture. Thank you so much.
thank you so much, Sanan, for a warm welcome. Uh, Thank you, everyone, for joining. It's my pleasure to present in front of the students from a very prestigious institute. It's always nice to share my experience and knowledge with students about technology. Sometimes students know a lot more about technology and tools than professionals in this digital age. So I really appreciate you taking the time. Um, as Sanan mentioned, uh, I would like to make this presentation as interactive as possible. So if you have any questions in between, please feel free to ask. I don't mind at all. If you can ask, if you want to ask to Sanan and he can transfer it to me, that's fine too. Um, Let me share my screen first. Uh, uh, is my screen visible to everyone?
Yes, sir.
Yes, sir. Thank you, Sanan. Um,
You need to share
so
your
again, thank
presentation.
you can see my presentation, right?
No, sir. Not now, sir.
Just let me do it again. Stop.
Yes, actually, we can see it.
You can see it?
Yes.
Just a second.
Oh, now it stopped.
Is it visible now?
Yes, sir.
Okay. Um, Thank you, Sana. Okay. So again, good morning, everyone. So today's topic is building information modeling and its relationship between architecture and technology. So as we know, world is changing drastically, and everything is going through digital age. And we have artificial intelligence, robots in manufacturing industry. But I feel there is a huge gap between construction and technology in most of the world. So in this presentation, I will focus on how to use building information modeling to advance the traditional construction practices. Um, I have seen construction companies, architects using BIM in North America or in Europe, but in most of the world, we're still using the same technologies, 2D technologies that we were using almost 20 and 30 years ago. So that's why we are not as efficient as compared to other manufacturing industry. So in this presentation, I'll talk about what exactly is BIM and why is technology so important in construction. I will also talk about integrated project delivery and common data platform. We'll discuss some BIM uses and BIM dimensions from how we go from 3D to 4D and 5D. I'll discuss BIM for architects, what are the tools architects can use, and what's the career for architects and everyone, for everyone in BIM industry. And in the last, I'll discuss a case study and the project that I'm currently working on. It's a Centennial College project here in Toronto, Canada. So before going into presentation, as Sun mentioned, my name is Amit Sharma. I'm a virtual design and construction coordinator here in Alliston, Toronto. I've been in construction industry for almost 5 years, but I've been in virtual design and construction industry for 1.5 years now. My education background is in architecture. I've done Bachelor's of Architecture from Guru Nanak Dev University, Amritsar. Then I moved to Canada for my post-graduation. I did two post-graduation, one in BIM lifecycle management and another one is in green architecture. I've been always a technology enthusiastic from my student age. I liked learning new softwares. That's why I choose to shift my career as a designer to be in a VDC industry. A little about myself, my company. Alliston is a world-leading construction company, and it's one of the biggest construction company in North America with $5 billion in revenue. It has gone from a small-scale general contractor firm to a multi-billion-dollar company. Its expertise is in sectors like pre-construction. We do designs, we do construction and operations. Below, you can see some of the famous project that Alliston has done in the past. The first one is the Rogers Centre, Toronto. It's one of the most iconic building in Toronto downtown. It usually all of the big sports events and music events, it happens in this stadium, and it was one of the first huge project Alliston has done. The second one is Art Gallery of Ontario, which was designed by none other than Frank Gehry, and it was again one of the most iconic building in Toronto. And it's the way Alliston developed its technologies, to maintain Frank Gehry's design and to build that, it was amazing. And the next one is the National Art Gallery in Ottawa, again, iconic building in Ottawa. The last one is Ryerson University campus in downtown Toronto. So again, like great company. If you want to check out any of the project, there's another huge projects that Alliston has done. If you want to take a look, feel free to visit their website, or if you want to see any career options, Alliston always hire international students for internship, for co-ops. So feel free to visit, and if you need any kind of information about those projects or other projects you see on their website, you can reach me out. I would happy to help you. So going into the BIM, the first thing is we have like traditional architectural practices. So I know you all must have seen this picture on the right, where we have in traditional times we have this huge halls and huge drafting tables where we have draftsmen and architects working on this huge huge projects with a lot of back pain. It was very inefficient way of working at that time as compared to now. It was very time consuming. It's very hard to store any kind of information they built. Everything was on paper, and it can destroy with time. And we don't have a lot of old buildings design in very good format, and it missed a lot of information. Then we moved to 2D CAD drafting drawings, and it's almost the same method of working. It was just we were doing that same thing making every lines from line to line in a CAD format using mouse and keyboard. But it was the same process. Again, there was a lot of time consumption, not so different from hand drafting. A lot of information get lost during that time. There was a huge communication gap. It's very hard to send those CAD drawings, and there are different versions of CAD drawings, and after the project is complete, you don't know which one is correct, because when the construction happens, a lot of changes happen on the site, and and the drawings do not usually change with that time. There's hundreds of design when hundreds of design at the end of the project, and you don't know which one is correct. So next one is, why is technology so important in construction industry? So there's been this study done by McKinsey and Company in 2012. On the right side, if you see, we have a graph between the productivity, the $1,000 per worker, and with the time from 1994 to 2012. The upper line is from the manufacturing industry. If you see, manufacturing industry productivity increased almost to double, but in construction industry it remained same and even declined. Because we didn't use any kind of technologies in construction. We were doing same things that we were doing like 20 years ago. So all this productivity decreased due to any kind of poor organization. In construction industry, usually we don't organize our stuff pretty well. We design our buildings. We left all the organization for the construction phase. We don't organize it in the design phase. In the construction phase, everything is expensive. Every delay is causing money. If it's time delay, time is equal to money. We're losing money there. So all the poor organization reduced its productivity. The second one is inadequate communication. So on a particular construction project, there's like maybe like hundreds of people joined from architects, from structure engineers, from electrical engineers, from mechanical engineers, estimators, and it's very hard for them to communicate at the same project. And whenever this communication happens, a lot of information get missed, and which leads to inefficient design or inefficient construction and operation. The third one is flawed performance management. We don't do any kind of analysis or performance analysis during the design phase. We leave it everything for its operation phase. We design our building, we construct our building, and we evaluate the performance later. But with the technology, now you can analyze all its life cost before the construction happens. You can simulate everything before the construction happens, and you can make those changes to make it more efficient. The last one is poor short-term planning. So in construction industry, we usually see we only plan for like next 2 or 3 weeks. But in huge projects, which goes from 3 to 5 years, we don't know what's going to happen. We plan a schedule, and sometimes we don't even know how it's going to look like after 3 years. With a lot of tools now, you can simulate all of the construction with the time. You can see after 3 years where we will be, which floor we will be. If it's a multi-story building, where exactly we will be, and you can make that process more efficient. You can cut out any kind of lags in the construction. The next one is McLeany curve. I don't know if you have seen it in the past. It's very famous in civil or like construction industry in general. It was done by Patrick McLeany, who's the principal architect of HOK Design Architecture firm. It's one of the biggest firms here. So in this graph, on one side we have effects, cost, and efforts. On the other side, we have preliminary design, operation phase. The first thing is the ability to impact cost and performance. So everything we do, everything we design, the effort and the cost at the starting is huge. this we can have the building 2 stories, we can have the building 10 story. All these decisions are made in the prelim design decision. But when we move from construction to operation phase, we don't make that kind of huge changes. We don't make any design decisions later. The second one is the cost of design changes. So if we change any kind of design in prelim design, it's going to cost very less. But as we move forward to construction and operation phase, if we make any kind of changes, that's going to cost a lot. It's going to cause delays. It's going to cost money, and it leads to inefficient project. The third line is the drafting-centric workflow, what we usually use in CAD formats. The third line, if you see the efforts we make in prelim design or detailed design, it's very low, but we make most of our efforts in construction document phase, and then it goes constant. But now we have BIM workflow. In BIM workflow, what we want to do is shift everything in detailed design phase. So we have decided, coordinated, communicated everything in design phase. So we don't have any kind of changes or efforts have to made in construction phase. We can just prefab everything in factories or plants and just assemble it on site. The next one is the life cycle management. As an architect, we usually always focus on the 15%. We usually always focus on design planning or the construction phase. We never think about its operations or maintenance phase. If you see from this diagram, the design cost and the construction cost is only 15%. The rest is 85%. So any decisions we make in that 15% is going to impact our whole operation and maintenance phase. So what we do in BIM, we analyze everything, we simulate everything in that design phase, so we can reduce the cost of our operations and maintenance phase in terms of energy, in terms of repairs or renovation. So next one we have what exactly is BIM. A lot of people, like, is it a software, is it a technology, or is it a process? Like, a lot of people think it's Revit. If you're using Revit, you're doing BIM, which is incorrect. Revit is kind of a tool for using BIM. There's a lot of other tools you can use instead of Revit and still be using BIM workflow and BIM technologies. So what exactly is BIM? BIM information modeling. Building information modeling is an intelligent 3D model-based process that gives architecture, engineering, and construction professionals the sight and tools to more efficiently plan, design, construct, and manage buildings and infrastructure. It is a highly collaborative process that allows architects, engineers, and contractors to design and construct within a same 3D model at the same time. The importance of I in BIM. Information, I stands for information in BIM, which is the most important part of it. Without I, it's just a 3D model which we can use only for visual purposes, or which cannot be, sometimes it's not even on scale. We make something, as an architect, we make something pretty, but when it's built on site, it's totally different. Here on this, I have an example of kind of information is attached to a wall. It's a screenshot of Revit. If you see here on the parameters, we have its dimensions, we have its areas, we have its U value, we have its acoustical rating, we have fire rating, specifications. This all data makes it very very easy and very efficient to use. We don't have to store a bunch of specifications or a lot of details or a lot of different sheets to store this information. All you have to do is just click on the wall and you have all the information you need in front of you in seconds. This information, usually on the big projects, there's like hundreds of documents that we deliver as a construction company, we deliver to owners. But in this digital age, all we can deliver is this digital model, which has all the information that they're going to need in their lifetime building. Then we arrange this information in uniformat and master format, which are the industry standards to store that information. Next, we have the construction, how we use BIM in different construction phases. We can use construct BIM from programming, from conceptual design to detail design. We can do analysis, we can do documentation, we can do fabrication, we can do the construction 4D and 5D model. I will explain every phase in detail, and at the end we have record model. We can use that record model again if we want to go into renovation or demolish that building. It helps in demolishing as well. If we know what kind of material we had, it's going to help us demolishing as well. So we use BIM in every phase, and it can improve the efficiency in every phase. The next we have is integrated project delivery in common data environment. So what IPD is, it is a construction project delivery method that seeks efficiency and involvement of all participants through all phases of design, fabrication, and construction. So in IPD, every stakeholder get involved at early stage. We don't design first and then bid it to later. Everyone is involved on a same BIM model. Everyone, architects, engineers, surveyors, clients, all the design decisions are making by a combined effort. And if anyone have any concerns in the starting, they can tell right away. We don't lose any kind of time or money in that phase. Integrated project delivery helps enhance collaboration. So as we know, everyone is involved in a single platform. Everyone is chatting with each other, and everyone is talking to each other. If we see any kind of issues, if as a contractor, you see any kind of issues, he can speak right away. It creates it creates a single source of truth. What it means is we have a single source of information, a single model. We don't have a bunch of documents. Sometimes in construction, you see, okay, my drawing is different from you. My drawings are different from you, because drawings get updated maybe every week or every 2 weeks. Their design changes during the construction. But if we have a centralized BIM model, everyone can see those changes. It improves efficiency and quality. So as we know, we are making these design decisions very quick. We are making all the decisions very quick. It can save our time, and it produce better quality of work. It also lowers the risk. So as an engineer, imagine if architect designed a building and then we send those drawings to engineers to make any kind of changes, to design the structure. But in this case, engineers are seeing those changes very first. If they see any issue, they can flag it. They can tell the architects, owners that that's wrong. It decreases the risk very low. Next, we have level of development. So LOD is a metric to measure how much information is added to the model. This is the standard we usually use in the BIM industry. If you can see in LOD 100, we only have the description of the chair and the manufacturer. As we move forward in the design development phase, we have its detailed description, its dimensions, its manufacturer, and in LOD, when we do documentation or in construction, it has its detailed information about its width, depth, height, its manufacturer. But when we deliver that model, we have its description, its warranty, its manufacturer, and the date of purchase. So in this case, chair is just an example. We can have this information for every element of the building, for any kind of lighting fixtures, any kind of mechanical equipment used in the building. We can have this information stored in just the model. We just click it and information is in front of you. The next is BIM uses. So this is a document prepared by Penn State University to identify any BIM goals at the starting of the project. It shows how we can use BIM to make our project more efficient in terms of cost. Here you can see from plan to operate phase, we have existing condition modeling, cost estimating, phase planning, site analysis. I'll talk most of it in detail in next slides. But at the starting of the project, what BIM managers do, they, according to their requirements, according to client requirements, they tick mark what they want to extract from the model. They tick mark and they work according to that. They make their execution plan according to that. The first thing is BIM existing conditioning, existing conditions. So this concept is usually used for renovation purposes, where we already have a building and there's a lot of elements. Can be structure, it can be mechanical, electrical. We usually have a laser scanner scan the whole place, and then we convert that scanner into point cloud, what you see on the top left corner of the building. Then we use that point cloud as a reference to make a BIM model. Now this BIM model can be used if we want to do any kind of renovation. We want to add something here. This information, maybe this whole information was on 2D drawings and it's not accurate. But now with the laser scanner, we have the exact dimension, exact same information, what we need to make any design changes. The next one is cost estimation. So cost estimation, it helps a lot architects or even engineers a lot to plan everything from conceptual base. So if you have used any kind of, if you've used ArchiCAD or Revit, you can export quantities in seconds. Whatever your design, if you are in a conceptual stage, you can export the quantities and see what's the cost of the building, and you can make your design decisions according to that. We don't want to run out money when we are in construction phase. Most of the time, a lot of times, what's the estimators estimate, it's not the correct value. You cannot calculate the correct value from 2D drawings. It's not possible. It's very time consuming. But with BIM model, you can extract the same amount of quantity in minutes. The next is phase planning. So in large scale projects, phase planning is one of the most important tasks during construction. We need to plan which phase to build first, according to considering the site condition. If we have any buildings around it, if you see on this diagram on the right, we have a building, then we can mark crane in 3D. We can plan the traffic around it. We can decide loading and unloading areas. We can decide the swing of the crane. It's very important to coordinate that in 3D, because in 2D drawings, you cannot see how it's going to look like when it's in higher dimensions. The next one is programming. So programming, it gets used in very initial stage of project to calculate any kind of areas, or if you want to, imagine if you develop a sketch or a concept and you want to know what kind of areas or we can extract from that concept. Here we can use the BIM model to have those quantities. We can see if it's feasible or not. The next one is site analysis. So in site analysis, in this process, we can place our model on actual site conditions virtually, and we can see how it's acting with the climate condition, with the geological conditions, and it can help designers or owners to place its building. We can, there's a software called Sapphira where you can see exactly if you place your building, if you orient your building on a 15-degree angle or the 20-degree angle, how much effect it's going to be on the building energy, how much effect it's going to be on the site condition, how much excavation you have to do. Everything can be calculated virtually before the construction happens, which is not possible in 2D drawings. The next one is design authoring. So design authoring here, we develop everything in 3D. We have a 3D design model, we have 3D mechanical model, we have 3D electrical model, and we can do the coordinations. We can see how much space we're going to need for our HVAC duct or our conduits, and we can visualize the building, how it's going to look like. There's some virtual reality tools where you can place your building virtually on the site. If you put your VR glasses, you can see the building, how it's going to look like on the site in real scale. The next one is structure analysis. So in structure analysis, we do all kind of loads. We calculate all kind of loads in the model. You don't have to do it manually. Software does that for you. You can calculate all the loads. What's the size of column and beams you're going to need for this building. You can calculate all those loads from the model. You can do this in Revit structure. You can analyze the earthquake effect or any kind of wind analysis, how it's affecting to your building. In a lot of high-rise building, it's very important to do those analysis, and we can make those design changes if we like taking an example of Burj Khalifa. Like they developed a 3D model in softwares, and they did those analysis virtually. Everything they did those analysis digitally, and that's how they came up with that design. That's how they made those building curvy, where they have to make those curves. The next one is lighting analysis. So as you can see on the right, this is a sketch from a software called Sapphira. You place your building on a correct position, on a correct coordinates, with the correct sun direction. You can see how your rooms are gonna look in natural light. If you can see here, where it's yellow, and it means it's highly lit room, and where you see the dark spots, it's dark. There's no sun in these rooms. So this analysis helps us a lot, designing the envelope of building. You can see what kind of shadow effects you're getting, what is the amount of light you're getting in your rooms in the deepest corners of the building. And this analysis helps a lot during the initial design stages, or even during the construction stages, choosing what kind of lighting fixture we're going to use. If we have a lot of natural lights, maybe we don't want to spend a lot of money on huge lights. We can calculate the luminous value from this analysis. The next one we have is energy analysis. So from our 3D model, you can calculate building's energy cost before the project is built. You can calculate how much electricity is going to use by putting the value of the kind of equipment, kind of lighting fixture you're using. You can calculate the water flow, the amount of water your toilet fixtures are using. You can do all the energy analysis. You can simulate before the construction has started. You can make those design changes. Initially, you can calculate that if you want to use 5-star products, or if it's easy to use 4-star projects. You can do those energy analysis with the detailed information. Next one we have is 3D coordination. So in 3D coordination, we usually do class detection, a lot of class detection. So imagine I have this. If you see here, I have a model from plumbing and I have a model from structure. There's a software called Navisworks. I select both of them and I put run a clash detection test. It gives me each and every spot where we have a coordination issue, where we have our pipes going through any kind of beams. And a lot of times you have seen, and maybe you have seen on the sites, like they have to make those changes on site where they break the beams or break the columns, which reduce the quality of work which can be which is also a safety issue. And but this kind of things happen. But if we coordinate everything during before the construction, you just can prefab everything and install it on site. You don't have to do anything on site. You can just assemble it on site. The next one is site utilization planning. So as you can see, this is one of the projects that we were working on. Here you see in downtown Toronto, there's like 5 high-rise building at the same time. There's huge cranes that are working on this project. You need to coordinate how the cranes are moving. You need to coordinate with the traffic flow because it's a live road. It's not blocked. You need to see where the trucks are coming from, where we have our loading and unloading zones. You can simulate this whole process. I will show you a video that we made later what we made from this project, and you can optimize your planning to make it build faster, or so we don't disturb any pre-existing building, or we don't disturb the traffic we have there. The next one we have is digital fabrication. So this BIM use, automation industry has been using this tools from years, from like 20 years. They make, like, imagine like cars, they make the 3D model of the car, and they put that in their machines, and robots made that. In construction industry, we building everything on site. We were not using any kind of these technologies in construction, which doesn't make any sense. We can do all the coordination in virtual manner, and we can build these pipes. We can build these pipes in the manufacturing plants or in factories, and just we can install it on site. But usually, what happens is there's a lot of coordination issues. That's why they do it on site. But if we have coordinated everything virtually, there's no need to coordinate on site. We can have everything coordinated and just install it on site. So the last two ones are record model and asset management. So the record model is the model we deliver at the end of the project to owner. It consists of all kind of information from design stage to construction phase. It has the type of equipment we used, its warranty, its manufacturer, all sort of information in a single model. Like usually at the end, before this BIM thing, at the end of the project, construction company used to deliver like 20 different kind of documents to the owner, and they store it in some basement. And after like 10 years, when they're doing some renovation, they don't know which information which is correct or incorrect. So in a record model, everything you have is one click away. You can have the manufacturer warranty attached to your model. You can see when the thing was installed, and it's kind of a live model which is used in asset management. Asset management, it's when we are doing any kind of maintenance on the buildings. So imagine if we are changing any kind of if we want to change a fire protection pump in a building after like 10 years, we don't have any kind of information in a building. If it was on a 2D sheets, we just have a markup of that fire pump. But in a 3D model, if you go there, you select that model, it will give you the manufacturer, and the manufacturer, if it's still in warranty, and all the specification that you need to install a new one or to fix a new one. It saves a lot of time and effort for asset management. As we seen from our previous diagram, 85% of the building cost is in asset management. So if we have a good record model which has everything included in it, it saves a lot of time for us in asset management. So the next concept is BIM dimensions. So again, as we know, like in dimensions, we have 1D model, like we have our existing conditions or any kind of reports that we have. 2D models that we usually use, 2D drawings or documentation. The BIM starts from the 3D model. In the 3D model, we have rendering walkthroughs, but when we go to 4D, it comes with time. We use time as a fourth dimension, cost as a 5 dimension, and performance as a 6 dimension. I'll explain everything in detail and how we're using it. So in 3D, usually, like everyone has, every stakeholder has their different models. Architects has their architect model. Structure engineers have their different model. We can coordinate them and we can visualize it, how it's going to look like. If there is any issues, that we can put on virtual reality glasses, and we can see if there's any coordination issues, and it enhances 3D visualization of the entire project. It streamlined communication and sharing of design expectation. It also enables easy collaboration between multiple teams. It reduces instance of rework. The next one we have is 4D. So 4D is when we use time as a fourth dimension. So in project, if you see on the right, the project like this, a huge project, we have to plan everything when we are, when we are casting which slab. There is, like, we cannot make every slab in one instance. We have to, divide that. I want to share a quick video with you, what we do and how we optimize this. Here. So it's one of the buildings we built in Toronto downtown. Shit. Just a sec. Just a few examples. Sure. Okay, I can use some other options. If you can see here, you can attach your construction schedule with the model, and you can see at what time exactly we are building, we are constructing what thing. We can see what kind of lags we have in our construction schedule, because in construction schedule usually are very lengthy, and it's very hard to understand how it's happening, when and how it's going to happen. With this simulation, we can see exactly what month or what year that the casting is happening. And if we see any kind of lags, if we see that there's a time lag between two casting of slabs, we can reduce that. But if you see, like, if I show you one of the example of construction schedule, like this is the construction schedule usually what we prepare, and it's very hard to understand, like there's some like bunch of things, and there's like the dates, and it's very hard to imagine when exactly this building's going to build, at what position, like if we are building concrete slabs, and we also developing the envelope at the same time. We can optimize our process as much as possible to simulate that construction virtually before going into actual construction. You see a lot of projects, like we've seen a lot of project in like in China or in US, like they say they have made this project in record time. That's how they do it usually. They simulate all the construction virtually and optimize the construction as much as possible before going to actual construction. So this is one of the tools. We can make this video in tool called Navisworks or Synchro. The next one is 5D, when we use cost as a fifth dimension. So imagine like in the building on the top right corner, this is the Museum of Human Rights in Winnipeg. So imagine like the building like this. How can you export the quantities? How can you export how much concrete are we going to use? It was for this project, it was very hard to bid. It was very hard to bid for the subcontractors to bid on this project, because you cannot calculate the cost or the quantity from 2D drawings for this kind of project. But if we had a model for this project, and it was very easy, we had everything exported in minutes, because all of the model was very detailed, and we can export the volume of the walls, the volume of the glass, and we can also calculate the number of glass we're going to use for this project. And like this dimension, it really helps a lot architects, engineers from the starting of project to calculate everything. It's helpful for architects to make decisions, because we can calculate, we can see if it's something is costing a lot. We do need, if it's in our budget or not. Do we need to make any design changes? The next one is when we use sixth dimension, energy as a sixth dimension. So as you saw in the first photograph, 85% of the building costs come from maintenance and operations. So in this process, you can use the model to simulate its lifetime cost. You can see how our building is going to act, how much solar solar panels we're going to need. You can place your building on exact coordinates, and you can see how much energy is being generated from these solar panels, how much energy consumption, how much energy is building consuming. You can calculate the whole building process in very initial stages, before the construction started. You can make those design changes very initial, so we don't have to pay a lot of money in its maintenance or in its operations. The sixth one is the facilities management. Again, when we have, like as I explained before, when we have our record model, it helps a lot for the facilities management. Imagine a building like a hospital, is a huge, like 500-bed hospital. There's like hundreds and thousands of mechanical, electrical equipment attached to it. If we save everything on Excel sheets, if we save all of the data on Excel sheets, it's very hard to track. But if we have everything in 3D manner, you can just click on the project. It will show you, what kind of project, what kind of equipment it is, and where it come from, with it, who's the manufacturer. If you want to replace it, you can see the manufacturer here. You can see the specification. You can see the warranty. So BIM plays a huge role in facilities management. Next one is BIM for architects. For architects, I guess architecture industry is using BIM from a long time, if we compare to other construction companies, as we compare to civil or structure. Like if we use BIM tools for architecture, if you see on the right side, this kind of designs, it's not possible on CAD. It's very hard. But with the tools like Dynamo on the left side, you can program everything, and it will make you the model. You don't have to do it manually. You just have to program it, and it will model it according to your requirements. It will be self-generated by the computer. You don't have to do anything. You can also use Revit. You can also use BIM for visualization purposes. So this rendering is from Enscape. I don't know if you're using it or not. Lumion is also a great tool. You can have your model live synced to Enscape, and you can make walkthroughs, or you can see how it's going to look like. It's a great tool. You can make your energy. You can do energy analysis. You can change your design according to that. You can do wind analysis. You can change your design according to that. So all of the BIM tools helps architects a lot to make the design decisions, to make the building more efficient in terms of cost or time. So again, this very cool thing. It's pretty new in BIM industry. It's called VR, virtual reality by Microsoft HoloLens. So in this technology, what we can do is we can make everything virtually, and then we can integrate that model with the current building. So imagine if we are doing a renovation in this kind of building, we have the building already, we can make a model, and we integrate that model in the existing condition. With the VR, you can see how it's going to look like if you have any kind of coordination issues. If you have to change your design, you can do that virtually. So it's an amazing tool. We usually use this on kind of industrial renovation project where we have a lot of services in the ceilings, and we want to add some more services. And we generate a model, then we integrate it with the actual site, and we can see if it's feasible or not. Again, very, very, very cool tool. It's a little expensive right now, but it saves a lot of money when we have to do renovations. You can measure anything. If you want to measure a distance between two things, you can use your fingers to do that. It's pretty amazing. Next one is career in BIM. You can be a BIM engineer, BIM architect. If you have a background in like any of these fields, you have a background in architecture, in structural engineering, mechanical, electrical engineering. Usually everyone starts from as a BIM engineer, as a BIM technician, where you model, where you do all the modeling. Then you get promoted to a BIM coordinator level. A BIM coordinator's job is to coordinate between all stakeholders. Like as in my current job, I coordinate with architects, structure engineers, mechanical engineers. I get a 3D model for everyone, and I integrate that in a single model, and I see if it's feasible or not. If I see any kind of issues, I flag it. I send back to mechanical or architects if they're responsible for that. So then we have BIM manager who uses, who handles 2 or 3 BIM coordinators or lead a large job. Then we have a BIM director who make decisions in a company, what kind of tools we're going to use, or any kind of trainings with those tools. Again, it's a booming career. It's a great field. If you are technology enthusiast, try look for career opportunities in BIM. As an architect, we already know a lot of softwares that people use in construction. You can usually like BIM people like they make more money than even architects and engineers sometimes, because we are saving a lot of money for the construction or the architects. So if you're interested in it, please feel free to look any career opportunities you find in India. Even in India, there are a lot of companies who are integrating BIM technologies in their workflow, and they always look for BIM people. So at the last, I have a case study from I have a case study that the project I'm currently working on. It's a Centennial College project in Toronto, Canada. This is a building you can see. It's going to look like this. We haven't even started the construction yet, but we are doing everything. We are making coordination virtually, everything we're doing digitally before the construction happened. So just a little bit about the project. It's a Centennial College project, a block expansion. The project owner is Centennial College. It's located in Progress Campus, Scarborough, Ontario. Pardon me. Project type is design build. It's a $85 million job. It's going to be 150,000 square feet area, and its completion date is in October 2022. These are the names of the architects and structural engineer, mechanical, electrical engineer we have on site. So about the location of the project, if you see on the blue ones, these are the existing building, what we have on campus, and this is the expansion joint of a block, what we are building right now. What makes the project so special? So it's going to be Ontario's first ever mass timber higher education facility. So mass timber, it's a lot of it's a timber beams and timber columns glued together and compressed under a with a heavy press, and we can it's all the load capacity of these columns are almost similar to concrete columns. Before that, like 2 years ago, it was not allowed to build more than 3-story building with the mass timber structure. But in Canada, it recently changed. The laws recently changed, and you can build more than 10-story building from this CLT, cross laminated timber structure. As you can see, the carbon emission from a timber building is very, very less as compared to concrete and steel building. And for this project, like Centennial College, their main focus was to make a sustainable building. So for this building, it's going to be a net zero carbon. For sustainability purposes, they are scoring for LEED Gold. So all of the building, all of the fixtures we're using, the kind of lights we're using. So we did all of those analysis before the building was during the design phases to make it more sustainable. So all of the BIM tools that I discussed before helped a lot to make this what we have right now. This building is going to be built according to Native American principle and values. So all the design concept is according to Native American culture. These are some of the views, how it's going to look like from inside. As you can see, everything wood. These are class CLT beams, columns. The roof is also going to be wood panels. And these are some of the sitting spaces. It's going to look like this concept is again came from indigenous people of Canadian and North American region. So importance of virtual design and construction in mass timber structure, especially for this structure. The first one is prefabrication. So all of those columns and everything you see here, it's going to be prefabricated in the factories or the plants. Everything's going to become in exact finished space, and we're just going to install it. So it's very important to do all the coordination before before the construction happens, so we don't have to make any kind of changes later, because it's not possible in prefabrication to make any changes later. We're going to do the coordination and again class detection to reduce cost, to do the constructability review. We can see in the 3D if there's any issues installing something, or installing some columns, or installing HVAC duct. I will show you some of the examples, what I do exactly on this job. We did quantity takeoffs, exact quantity takeoffs from the model. How much concrete are we going to use? How much wood is going to be used on this project? How much steel is going to be used on this project? Everything was exported from Revit BIM model, and it was precisely correct. We did a 4D scheduling, progress tracking, the 4D model I showed you, where we simulate the construction virtually, so we can optimize it when we have to do it in reality. So also to transfer to track transportation and delivery logistics. For VDC workflow for this project, I just want to show you like what's my job in this project, what I do as a VDC coordinator on this project. And first, we have architecture, structure, mechanical, electrical, everyone working on BIM 360. I don't know if you have used or know about BIM 360 before. So it's kind of a cloud-based platform which is connected to your current Revit model. Okay, as an architect, imagine if I'm an architect and I'm working on a model here. If you see the button called synchronize here, if I synchronize, it's going to synchronize to everyone, all the mechanical team working on their model. If I make some change here, it's going to automatically show in their model, in their position. So they're going to change their mechanical design or HVAC duct design, plumbing design according to that. We don't have to send drawings each and every time. This is a single live model. Everyone is working on that. Then I download these models and I export that into Navisworks, software called Navisworks. So in Navisworks, I have everything. I have model from, I have a mechanical model, if you can see. I have a mechanical model, everything in detail. I have structure model. Usually what I do as a BIM, as a VDC coordinator here, I get model from everyone. And there's a tool called here, class detection. Okay. Then I just place like here, if you can see, I did a class detection between electrical and structure, pipe and electrical. Okay. I just select those two models and run a class detection. It will show me exactly, where we have a class between two fields. If our pipes are going through the beams, if our pipes are going through HVAC ducts. Let me show you a class example. So imagine like position like this. Here I can see, if I do a class section, that one of my pipe is going through the structure wall. Okay. What I do is I do a class section. I see an issue. I export this model in a tool called Revisto. So in Revisto, I have a tool called Revisto here. Everyone from architects, from mechanical engineers, everyone is added to that. It's a cloud-based platform. And if I see in some issue from Navisworks class detection, I come here, I mark that issue. If I mark that issue, that this conduit is going through the beam, it's supposed to go down the beam. And I can tag that person here. Like if you see my screen, I've tagged Joe Bison for it. and I can give a title. It's a conduit clashing with timber beam. It's going to give a notification to Joe that Amit has tagged you in something and there's a coordination issues. And he can see it on his screen. And if he has any comments, he can leave me a comments here. Everyone on the team can see this coordination issues. And it's a joint combined effort to make this building, everything is coordinated, everything is clash free. So if you see like here, like imagine doing the coordination of these many pipes in 2D in 2D platforms. It's not possible. Okay, this was everything. If you are seeing this the signs, these were all the coordination issues there. Like I marked the coordination issues and they make that design changes according to that. So we have models from fire protection, from plumbing, from HVAC. And what they do is like they send me model and I see them if it fits perfectly. If I see some issues, like if I see like imagine if I see issues like that, I mark it, I send it to like Devin here, and I send the reports. You can export a report from that. I export a report like that from it, and they can see their clashes here. They can see the issues, they can see the title, fire protection pipe clashing with the duct. It shows the assigned name, shows the date, it shows the comments they have left before. And if they want to see the exact position of that clash, all they have to do is open in Revisto. And it's going to take exactly to the same position. And they can see, they can look around. Okay, and when they fix this position, this Revisto, it's attached to their Revit model. Okay, it's a live model. Whenever they fix this issue, it's going to get fixed here. So amazing tool, very easy to coordinate. Like before that, imagine doing this coordination, sending one by one, writing emails to everyone, please fix this issue. There's pipe clashing with the duct. It's very hard, but on this platform, everyone is there. We can see like I can tag architects, I can tag mechanical engineers, I can tag fire protection guys. And also like if imagine I have 2D drawings here. I have a 2D drawing here. And I want to see how it's gonna, if I want to see how it's gonna look at this position, all I have to do is press this in 3D. It's gonna overlap the 2D sheet over the 3D, and if I can see the details here exact, like how it's gonna look like. So a lot of the construction people, civil people, they still use 2D drawings. They are more they are more flexible with drawings. So it's a great tool. They can see 2D drawings overlaid over the 3D. So again, like amazing tool to coordinate. And yes, that is it from my side. Thank you so much for joining. If you have any questions, we can start now. Sanan, over to you.
Yeah, thank you, sir, for your presentation. Yes, students, anyone, if you want to ask any question, you can. Any questions, students? Third year, fourth year, second year? Okay, anyone from faculties? You want to discuss anything?
Hi, Amit. I am Harsh.
Hi,
Hello.
Harsh.
Hi. I am assistant professor in Department of Civil Engineering. So I just
Okay.
want to ask, what are the differences do you see in Canadian construction industry as compared to India?
Okay. Good question. So I feel like in Indian construction industry, we are still technology wise, we are not that advanced as compared to as compared to Canadian construction industry. We don't take safety or safety as a, we don't take safety measures, and I feel like in Canadian North American construction industry is very advanced in terms of the kind of tools they use, and the again it at the end it comes to how much money we're spending, but still I feel like it's very advanced as compared to India, but for this and for technologies for this, I guess this they've been outsourcing a lot of these technologies from India. So all of the projects you see here, a lot of construction companies use Indian companies um, to make these models or make this thing happens. Um, so yeah,
Okay. Thank you, Amit.
you're welcome.
So this is Yash Sharma from fourth year.
Hi,
Sir,
Yash.
I wanted to ask, is the BMI software worldwide recognized, or is just the Canadian countries who are using the software and producing it, the drawings and all?
So there's a lot of softwares. Like there's not just single software, what we call BIM. BIM is kind of a set of softwares. Like we have Revit. It's part of the BIM. There's ArchiCAD. There's Bentley. Um, as everyone know, like Autodesk is a huge company. Most of the countries use Autodesk products. But if we go to Scandinavian countries, they use Bentley products, which is again very good. So it's not like every company they use different set of softwares. And the good thing is now with the standardized of how the software's data is processed, you can use one software's data, like you can use Revit's data in some other software and it's going to come as same. You don't have to, if imagine if I'm a mechanical engineer and I'm using different software than architects, it's still a same 3D concept. So the softwares like Revisto, you can still integrate two models together. It's very like before that, if we have two different software, it was hard to integrate that, and like it was defined in this initial stages that you have to use only this version, like Revit 2019, and the file won't open in Revit 2020 or like in earlier version, but it's very easy.
Thank you, sir. And
No
I
problem.
wanted to ask one more. Sir,
Yeah.
is the software compatible with this Lumion or other rendering softwares if we want to make the model on BIM and then render it on something else?
Exactly. You can use, you can export your Revit model. If you, I don't know if you use Revit or not, like you can export your Revit model um, to Lumion, or you can export your model to Enscape. So I don't know if you used Enscape or not. Like it's a live synchronized software. So you can make renderings and walkthroughs in a live. You can if you're working on right side by side, you can see how your building is going to look like in a rendered way. So Enscape, look for a software called Enscape, Enscape. Enscape, it's a great software.
Thank you so much, sir.
No problem. Any
Um,
more questions?
yes, sir. Hello, I am an assistant professor, Ankita. I would like to ask a question keeping in line with the question that Yash had asked right now. Could you provide us a holistic list of the different softwares that maybe the students can start with just so they can get a hang of how this domain of BIM functions? Like you are talking about different softwares altogether and the various interfaces where we can work in them combinedly.
Exactly. I can provide the list to I can send the list of the softwares that architects can use. Like currently, Revit is very famous. Everyone, I guess, in India also everyone
Yes.
knows Revit. Then
Yeah.
there's ArchiCAD.
Yeah.
Then we have Bentley software. Bentley is a company which is very famous in Europe. So Bentley also make it's a company like Autodesk. They make a lot of construction softwares. So there is software called 3D CAD.
Okay.
So
So
I
like
can
we
send you a list of bunch of other softwares which students can use and start learn.
okay. That will be very helpful, sir. Thank you.
No problem. Thank you.
One more question.
Sure.
Sir, I wanted to ask if we are willing to learn the softwares, different softwares. So, where can I find the platform to learn correctly or can get the guidance?
Okay. Oh, there's bunch of different platforms where you can learn the software. I don't know if you have access for LinkedIn Learning. I guess it's free for students. You can see, you can look into LinkedIn Learning, and there's a lot of videos on different softwares, and there's a huge course for every software, from basics to advanced level for every software. So LinkedIn Learning is a very good tool. Again, you can go to a lot of software have their own tutorials free. So if you start there, if you look for their website, they always have this blog or a video tutorial section where you can start learning for software. And these software are usually free for students. So you can if you can download it for free and start using it.
Thank you, sir.
Hello, I have one question to Mr. Amit. Hello, Amit. This is Tejindra, Assistant Professor from Architecture Department. My question to you is normally when we are working on any architecture project, we start with the basic concepts, design development, and then finally we move to the structures and then HYAC and everything. So, and when you're working in the BIM, the BIM software, so you mentioned one aspect like we can be very efficient in terms of design, we can be very efficient in terms of let's say understanding the structures or maybe delivering the structures or maybe the finally how we make a record of different things and delivering it to the client and all of that. So my question here is how efficient is it like in terms of the time that it takes from the design stage to the final stage of managing different things in the building, like let's say for the structures or maybe HYAC and everything. So is it a kind of parallel thing that like kind of happens in the BIM, or is it like a general practice like first we finalize something then we
No, exactly. Like in BIM workflows, usually what happen, like it starts from architects anyways. Like architects model a sketch. Architects make a sketch model of the building they are going to make, and when that sketch, when like it's a prelim design, all the other consultants get added to that project. So they start designing HVAC or electrical stuff in a concept way on that concept model. So everyone is working on a single platform at the same time. So it's very cost efficient, it's very time efficient. And if architects make some changes, it automatically reflects on HVAC designs. They can change their design instantly. So it's very cost effective and it's very time effective.
okay, thank you so much, Amit. That's really uh, wonderful to know actually. because otherwise I was thinking maybe that may not be possible, but when it gets reflected automatically, that's I think definitely wonderful to know.
Everything is usually on the cloud-based platform, so it's great how these things work now. Whatever we changes, it changes automatically in every other consult. Everyone is working on a single model and on a single platform. It's on a cloud and it's fast now. You don't have to spend a lot of money on your computers. Everything is cloud-based.
Okay. Also, I'm very happy to know that still we are like there is some value to the sketches of the architects, the concepts that we make,
Of
by
course,
hand.
of course. Yes.
So it's like initially my impression was maybe the entire the working environment or maybe the culture of architecture is moving towards much of computer based programming. So, but I think it's good to know still we have some say in terms
I,
of
I guess
ideas and
everything starts with
conceptions.
everything. Yes, everything start with the hand sketch drawings. But like if you see these softwares helps architects a lot. You know, like sometimes if we see some very curvy buildings, and it's very hard to show those drawings in 2D format, and it looks totally different we what we think in like if we are making some sketches, but when we attach scale to it, when we start sketching according to scale in 3D, it looks so totally different. So I guess even in the sketches phase, like obviously everything starts from a blank paper, but for the sketches, if we are using softwares, even SketchUp also, like it helps a lot understanding the building in 3D manner.
So just to put it in a single line, maybe I can say that it's a way of removing the barriers of communication and being
Exactly.
very efficient in communicating what you actually wanted to, like showing the client how it actually comes up
Thumbs
in a
up.
very
Yes.
short amount of time. Yeah, thank you so much. Thank you.
Thank you.
Hello, Architect Amit Sharma. This is Manmeet
I will.
from DIT University, Assistant Professor. So I also have one question. So I would like to know that what are the challenges architects in Canada face while executing some project? How are they different from the ones which we face in India?
Okay. I haven't worked in Canadian architecture offices. I always been in the construction side, but I guess the challenges are more into it's about the communication. Like in India, we see architects as a boss. He's the principal consultant. But here, if everyone is involved at the same stage, it's everyone's combined decision, which is good. So there's not huge challenges that I've faced or known of, but
Like we
maybe
see in India, we often see that sometimes even we have a plan saying something different, and we see an executed project saying something different. So such kind of blunders do happen somewhere at some part of our country. So
yeah.
I feel the such things are at a very minimal stage, or are they equivalent as compared to Indian context?
It's very minimal. Like in
It's very
lot of
minimal.
in lot of like if we are thinking about submitting our plans or drawings to uh, like city or city council, like usually they also submit that 3D model. So whenever they have that model or whenever they have those drawings in detail, those blunders, it's less as compared to, I guess, in India. It's in India sometimes we can manipulate that design later. Once our drawings are passed, we can change it later. But here, if government have your if the city council have your 3D model, what exactly was built on site, they can see, they can match that information with the building at any time. So it's it's very helpful when we have a digital model, I guess.
Thank you so much. It was really very nice looking
Thank
at
you,
such a
Anvit.
wonderful presentation. Thank you so much.
Thank you, Anvit. Nice talking to you.
Same here.
Any further
Yes.
questions?
Yes, I mean, I would like to ask one question is like, how can we use BIM to like decrease the life cycle cost of a building?
Yeah, great question. Again, like the tools we used, like the tool, the tools we use, like lighting analysis or energy analysis, or like these tools helps us a lot to simulate everything before the construction happens. So we if we like for example, if we are choosing a kind of lighting fixtures, and there's some kind of value added to that, there's some that uh, this fixture used this amount of energy for, if if we use it for 2 hours, you can simulate that, and you can, with the analysis tools, you can make the whole make the whole life cycle cost. And it helps us to, choose the right amount of lighting fixtures, or even like designing any kind of um, making any design decision, if we want our windows to be big or to be small in other shapes, so we can reduce the energy cost. So these set of tools helps us a lot to reduce the life cycle cost.
Yeah. Okay. Thanks, Amit, for your answer.
Thank you,
Okay.
Saman.
Anyone else want to ask anything? You can ask. Okay. No one.
Okay, thank you so much. So, on behalf of School of Architecture and Design, I would really like to thank architect Amit Sharma for taking out time from his busy schedule and sharing his valuable experience with our students. I'm sure they would have benefited hugely from this lecture, and it will help them in getting a deeper understanding on the aspects of technology and architecture. And the demonstration, sir, that you included on BRIM 360 in the ending, that was very impressive. It must have acted as an eye opener for most of our students, since like right now in our country we don't deal with the multiple interfaces and working on so many softwares simultaneously, getting to know at the exact amount, where's the problem coming up, how we can solve it out. So the ending, the demonstration, personally I feel as a faculty also was like very much as an impressive thing. And we know it must have been really hard for you considering the time zone differential. I think it's
Nope.
almost past, yeah, it's almost past midnight in Canada right now.
Yeah, it's
We
2 a.m. here, but I guess it's fine.
Thank you so much, sir, for like adjusting your time according to our time. We will
No
definitely look
problem.
forward to hearing more from you once again. Thank you so much, sir. We are really grateful to
Thank
you.
you, ma'am. It was my pleasure. Thank you.
Thank you so much, sir.
Thank
And
you.
thank you the rest of you for joining us and keeping up the decorum of the meeting.
Thank you, everyone, for if you have any further questions, you can always, contact me. I'm going to leave my contact information with Sanan sir, and you can take it from. If you have any further question, just let me know. Thank you so much.
Thank you, sir.
Thank you, Amit, for your time. Thank you so much.
Thank you, Sanan sir. Bye.
Thank you, sir.
Okay, you guys can leave. Thank you so much for your attention.